the Sun's dark companion and the physics of equilibrium. By RF Unbended Reality, astronomers know about the perturbations in the orbits of Uranus and Neptune for 2 centuries now, but have yet to come up with a specific cause of the explanation for this, at least officially. They don't know why this is happening. What's causing them to tilt their orbits? The first of these anomalies was observed soon after the discovery of Uranus in 1781, which many thought the later discovery of Neptune in 1846 would be able to explain, but it was not to be. In fact, Neptune was found to have orbital irregularities of its own, and so the search for the unseen planet X or Nibiru or Planet 9 or Wormwood, various names, responsible for the problem continued. The search carried over to the 20th century and the discovery of Pluto in 1930, which astronomers of the day had hoped was the missing planet that would resolve the long-standing problem, but its mass turned out to be much too small to affect either of the vastly large planets, the Jovian planets, Uranus and Neptune. NASA became heavily involved with the problem in the early 1970s with many years of computer studies, observations, and satellite probes to follow, targeted at finding the responsible source. And now we have the Lucy probe that just went out yesterday to study the Jupiter asteroid. So it will be in that area. With the view that the object was probably very dim, invisible light, and more likely to be found in the infrared frequency band.
In this series, I'm going to teach you about brain and heart coherence. And with this knowledge, what if you could strengthen your immune system by changing your thoughts and feelings? To be more present, to make better decisions, to think beyond the limitations.
Red astronomical satellite IRIS, January 1938. And in December of that year, an article appeared on the front page of the prestigious Washington Post, announcing that the probe had found a candidate source and imaged it twice at a distance of about 530 AU. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below. 1 AU is the distance between our Earth and the Sun, which is about 93 million miles. So this one was at 530 AU, away in the constellation Orion. A number of articles in the national press followed, and the last one appeared in U.S. News and World Report in September of 1984. That article was withdrawn the following week. The subject was dropped from news coverage, and NASA officially denies it ever existed. Isn't that very strange? Why is that? Now, the story of Planet X went through a similar media cycle. NASA launched Pioneer 10 and 11 in 1972 with the express purpose of looking for Planet X, although the goal only came out years later. The media announcement in 1983 primarily dealt with a very remote object which would have to be fairly large at such a distance and account for the orbital perturbations of the large Jovian planets in any case. And this left the logical venues of speculation about Planet X, Planet 9, Nibiru, Wormwood unaffected, since there was no announced observations to contest. That changed in 1992. In November of that year, Pioneer 10 began sensing a gravitational pull from something that lasted several weeks, a signal NASA had hoped to receive based on where they estimated the unseen planet might be found. NASA scientists, in collaboration with a British astronomer, published an in-depth analysis of the Pioneer data in 2 journal articles that appeared in 1995 and 1999, in which they proposed that a planet-sized object most likely existed at about a distance of 56 AU from our Sun in the constellation Taurus. After the second paper's appearance, the media the discussion stopped once again. The agency now officially denies that Pioneer 10 had detected what they announced and that Planet X exists at all. Even more amazing yet is that both NASA and conventional astronomers are now saying that there really is no unexplained perturbation in the Uranus and Neptune orbits, and that there never was. It was all an unfortunate mistake, they said. The thousands of misguided astronomers over the globe who have been immersed in the problem since 1781 had all gotten it wrong because of small errors in the mass estimates of the two bodies, but with that correction, the orbits are now recognized as being perfectly well behaved. No unseen object is bothering these two planets. Everything is just fine. Nothing to be concerned about. Move along. A history of this research is found in summary in the beginning of the previous study by the author, and in extensive detail in the excellent book on the website of Italian research journalist Luca Santamburlo. Two other researchers who have also produced a veritable wealth of related data, articles, and books and insight on the subject are Andy Lloyd and Barry Wormskessel. What's beyond Pluto? Now, in the previous study, it was argued that whether anomalies in the orbits of Uranus and Neptune exist or not, something about the solar system's arrangement is very strange in any case. The mass of the Sun contains over 99.9% of the mass of the entire known solar system, and yet less than 4% of its angular momentum. From classical physics, we know that angular momentum is always conserved in a closed system. So even though various processes are known to rob a star of its angular momentum over time, it seems strange, nevertheless, that such a gross disparity can exist between the two. That disparity, along with the solar system's missing angular momentum, was explained in that study, and the basis of the argument centered on determining an estimate of the lower bound for the solar system's current angular momentum, developed from recent observations and theoretical work regarding the evolution of protostellar disks, similar to the one that gave birth to our solar system. The estimate for our own protostellar disk angular momentum was found to be about 2,000% larger than its current value, which was used to suggest that astronomy's conventional reckoning of the solar system's current angular momentum is considerably low, and that a large object should be lurking somewhere in the outer reaches of the Sun's influence that accounts for the difference. The analysis showed that the missing angular momentum could be explained by a binary companion of our Sun, possibly a brown dwarf, with a mass some 2 to 10 times greater than Jupiter's, which is huge, of course, and a period of some 5,000 years or greater. Although the argument presented was consistent with known models of the solar system based on the most current research, it would still be highly desirable to find supporting rationale based on the only current observable data. Short of an actual observation, is there any currently measurable evidence we can use to derive support for that study's claims? And fortunately, yes, there is. There is Broca's rule. Celestial objects tend to form stable formations, he says, because of the way they balance energy. Each member of such a system moving through system space, it's like when two children hold hands and they go around and around. They have to, they're balanced when they have the same energy and go around and around. Now, each member of such a system moving through space under the influence of only the system's collective gravitational field acquires two forms of energy: the kinetic energy of motion and the potential energy of gravitational attraction that binds the member to the collective. The way objects move in the system is determined by both. Bodies in such a system can be in completely helter-skelter, random station of motion, or they can merely look helter-skelter but actually be in a highly coordinated state of equilibrium. So how can we tell the difference? The answer comes from an amazing discovery of 19th century physics called the Virial Theorem, described in 1870 by German physicist Rudolf Clausius, father of the second law of thermodynamics. The Viral Theorem has several forms that apply to a wide range of systems acting under various kinds of force field, but for the above collection of objects moving under the field, the theorem statement is concise. The system of objects is in a state of equilibrium if twice its average kinetic energy plus the average gravitational potential energy binding the bodies of the system is zero, or nearly so. The negative gravitational energy holding the system together is twice the positive energy of motion that can pull it apart, which is why galaxies persist as bound structures for billions of years. The delicate energy balance of such a system is very powerful, and yet the theorem's condition for equilibrium is actually very lenient. There is no prohibition against objects in equilibrium from moving chaotically, which they very often do, nor is there a requirement for the system as a whole to be in thermodynamic equilibrium, which it is invariably not. The mechanical energy of the systems is the sole governance influence. Celestial systems tend to edge their way towards equilibrium automatically, given enough time, no accretion or other perturbation processes going on, and no significantly large objects careening through the system, disrupting things. This is the second law of thermodynamics in action. One such system that achieved such a balanced state is our own planetary system, which satisfies the Viral Theorem very precisely. Not only is the theorem satisfied for the average motion of all the planets collectively, but each planet and sun pair satisfies it individually as well. And this may seem like a fortunate state of affairs, but in fact it leads to problems. Beginning in the early 1960s, German astronomer Peter Broch at the University of Bonn wrote several groundbreaking papers about the amazing property of celestial systems in equilibrium. Canadian physicist Paul Wesson picked up the work in the mid-80s and produced another set of papers and more decades of research and fully supported and advanced Broch's original findings, which is now an accepted effect of conventional astronomy, although virtually unheard of outside the field. By examining a large collection of celestial systems, Broch showed empirically that if a gravitational system is in equilibrium per the Virial Theorem, and its average density decreases roughly as the universe square of the distance from the system's center of gravity, then the system's orbital angular momentum is approximately proportional to the square of its total mass. His analysis showed that the rule, hereafter referred to as Broch's rule, is extremely general and has been shown to work for virtually all celestial systems, including galaxies and galaxy clusters, star clusters, planetary systems, binary and higher multiple star systems, which together span over 30 orders of magnitude. So yeah, there is equilibrium. It even works reasonably well for systems which different fall-off rates for density than the inverse square profile. Now this is a lot of details here with various calculations, but basically it has to do with the balance of mass and energy. We don't have a whole story, perhaps ever will, but we do have some very interesting data that we can use to assess the situation following analysis. And it's got a lot more calculations here, but the bottom line, the standard reckoning of solar systems' angular momentum is inconsistent with established physics and therefore highly doubtful. Whatever the reason may be, we know it has nothing to do with instabilities in planetary motion, because applying the Virial Theorem to the solar system, the motions of the planets are in a strong state of equilibrium. But this very fact is also the clue that something is wrong. If the solar system is in perfect equilibrium and its density follows an inverse square law, then it matches the conditions of Broch's rule precisely and should be close to his predictions of the solar system's angular momentum. One would think there would be 25 to 30% or so at least. That's a chance. But it's clearly not. It's off by almost 1,000%. So this implies that something significant is not accounted for. The conventional value of the solar system's angular momentum is simply much too small. The study proposes that a binary companion of our Sun is the cause of this. The analysis shows that a dark body of about 1 to 2 Jupiter masses adds relatively little additional mass to the solar system proportionally, and yet given an appropriate orbital period, the body can provide enough angular momentum to close the gap to account for the discrepancy uncovered by Beaufort rule. Now, given that each Sun-planet pair satisfies the Virial Theorem, there is also every reason to believe the Sun and dark companion pair will as well, which is to say that equilibrium throughout the expanded solar system should be preserved even if such an object exists. Now, evidence from the Kuiper Belt. Recent discoveries in deep field astronomy strongly support the likelihood that somewhere in the Kuiper Belt, a large object is orbiting our Sun. A major clue came from Mount Palomar Observatory in 2003 with the discovery of the extremely unusual dwarf planet Sedna 90377. With an orbital period of an amazing 11,400 years, it was supposedly much too long and its comet-like orbit way too elliptical for an object so large, but there it was. Researchers studied it for some time, agreed that it was an unexplained anomaly of some sort, shrugging their shoulders, and they moved on. But then about 9 years after that, another one showed up, dwarf planet 2012, called Biden, with a period of over 4,200 years, was discovered in the Cerro Tololo Observatory in northern Chile in the fall of 2012. Biden's orbit is less extreme than Sedna's, but it still has an outsized period of planetary standards, a narrow cometary orbit, and a mass over half the size of Sedna. And even with the highly elliptical orbits of the two unusual objects, their perihelia are so large, both more than 75 AUs, that they always stay well outside the orbit of Pluto. Why should two anomalies look so much the same? The conclusion. The solar system has a number of anomalies, properties that imply the existence of one or more large, uncatalogued objects orbiting our Sun. Most of the recent studies that predict this possibly have focused on irregularities in the motions of orbiting bodies observed over the last several decades, and the study, on the other hand, focuses specifically on the solar system's high degree of equilibrium. The bodies of the inner solar system, which contain over 99.99% of the whole, satisfies the Virial Theorem energy distribution. Now, the solar system is clearly in a strong state of equilibrium. If a celestial system is in equilibrium and its density profile follows an inverse square law of existence, which the solar system conforms to on both counts, then the system's orbital angular momentum and mass should be closely related to Gross's law. Supporting evidence from the Kuiper Belt indicates that the Sun has large distance companion. The discovery of two dwarf planets Sedna and Biden, with their extremely long periods and highly elliptical orbits, viewed as so unusual that it seemed to several astronomers that something else may be involved. Long period comets and asteroids arriving in the inner solar system should be coming from all directions, all things being equal, but that is not what the data shows. Several studies have shown that the strong bias exists in which part of the sky these objects came from and how their orbits seem to bunch together in similar ways near the Sun. Something, therefore, is influencing these distant objects, and astronomers are now using past observations to figure out where it is and how far away. The current estimates vary widely, and the analysis of the object's angular momentum presented here has not yet been factored in, but at least astronomers are now focused on the heart of the problem. So we have to stay tuned. This was by Scatamburlo, and it's on Bended Reality. Please leave your comments. Thank you for your support.